Hello everyone, welcome to Kwiantion Engineering YouTube channel. Today I took a lesson number 8, pressurization components, right? So this is the last lesson regarding pressurization system. Until now, the subscribers and the people who watch this my YouTube channel, I'm really thankful for everyone. And I think I will take more lessons, and for last week I was a little bit busy, so I couldn't take a lesson for you, so I decided to make this lesson for this week. If you still not watch my previous videos, please watch, and it will be helpful for your knowledge. And please share these videos with your social media platform, and you can share with your friends, relatives, and anyone who like to learn about aircraft maintenance. All right, so now let's go to the lesson. All right, so today lesson is chapter 21, air conditioning system, pressurization, lesson number 8, components. All right. Okay, so let's go to the overview. In this lesson, you will identify and locate the components of the pressurization system. Okay, in this lesson, you will identify and locate the components of the pressurization system. All right, so now let's go to the lesson content. Okay, so under lesson content, you can learn the first one, cabin pressure controllers. Okay, and the next one, outflow valve. Then the valve assembly, electronic actuators, and gearbox assembly, and the last one as a safety valve. All right. Okay, so let's go to the first one, is cabin pressure controller. Okay, you can see the cabin pressure controller. It is situated in the forward avionics compartment. Okay, you can see the cabin pressure controller here. It is 95 VU rack. Okay, you can see the rough schematic over there. The cabin pressure controller is here, and here is the electrical connectors. It is okay. And this is the rack. Okay, this is the rack, and here the 95 VU, and here's the 96 VU. All right. Okay, so the CPC1, cabin pressure controller 1 and cabin pressure controller 2 are interchangeable and provide with the system identification pins. Okay, so each R is equipped with pressure transducer module of the DMS pressure sensor type. All right, just remember each R is equipped with pressure transducer module of the DMS pressure sensor type. All right. Okay, now let's go to the next one, second one, outflow valve. Okay, outflow valve, you can see it is situated in the rear side of the aircraft, rear side, the right side. All right, so you can see the outflow valve over there. You can see the actuator electronic boxes, system 1 and system 2, and the auto motors over there. Here is the auto motors, and the manual motor is here. All right, so this is the actual view of outflow valve exterior. When you look at from exterior, you can see like this. All right. Okay, so the skin-mounted outflow valve. Skin-mounted outflow valve is of the dual gate and motor-driven type design. This is skin-mounted outflow valve is of the dual gate and motor-driven type design. So it consists of a valve assembly, a frame, and 2 gates. Okay, a valve assembly, the frame, and 2 gates, and the 2 electronic actuators. You can see the 2 electronic actuators. These are 2 electronic actuators boxes, and a single electronic board connected to its associated cabin pressure controller via RS422 bus. And a gearbox assembly, they have a gearbox assembly, 2 automatic motor, okay, 2 automatic motors, gearbox, and feedback assembly. All right. Okay, now let's go to the outflow valve. You can see the first one, valve assembly. All right, you can see the valve assembly. Right, you can see the outflow valve body has 2 gates. Right, outflow valve body has 2 gates. You can see they have 2 gates, one forward and one aft. One forward and one aft, and the gates are installed in the rectangular frame. Okay, you can see the gates are installed in the rectangular frame. Okay, right. So the forward gate opens for outwards. Right, the forward gate open outwards and is mechanically connected to the aft gate. All right, so the aft gate open inwards. Right, the forward gate opens outwards and the aft gate open inwards and is mechanically connected to the gearbox and the forward gate. All right, you can see here, this is a forward gate over there, and this is the bonding strap. Bonding strap in everything is bonded in aircraft. Right, so the next one is the F gate. This is the F gate, and this is the valve body. All right, and this is the gearbox. Here is the gearbox. All right, okay. Now let's go to the next one here, right? Electronic actuators, right? So let's see. The electronic actuator modules receive a position reference signal. The electronic actuator modules receive a position reference signal, desired outflow valve position from the controller. So the signal is compared with the outflow valve actual position. The electronic module then drives the outflow valve until its position matches the desired one. All right. Okay, you can see the motor controller 1, module 1, and motor controller module 2, right? So the next one, the pressure switch is installed in each box, right? The pressure switch is installed in each box. It operates independently from the automatic operation. All right, next one, it closes the outflow valve, right? Outflow valve closes if the pressure in the fuselage, if the pressure inside the fuselage is less than the atmospheric pressure at an altitude of 15,000 feet. Just remember about it. Okay, you can see the electronic actuator 1, and here is the electronic actuator 2, right? All right, so now let's go to the gearbox assembly. Gearbox assembly, right? Okay, so the gearbox transmit the movement, right? The gearbox transmit the movement for the activated motor to the outflow valve flap. Okay, so a mechanical stop limits the rotation of the drive shaft for the valve flap movement. All right. Okay, so the feedback module is a triple potentiometer, right? The feedback module is a triple potentiometer integrated with the gearbox, right? The gearbox and the feedback assembly. Here, the feedback module is a triple potentiometer. Just remember, right? Feedback assembly is a triple potentiometer integrated with the gearbox, and it sends data to the cabin pressure controller. You can see the purpose of the triple potentiometer is send data to the cabin pressure controller. There are two brushless DC motors, right? There are two brushless DC motors for automatic control. Here are the two motors, and each motor has an integral electromechanical brake. And the manual motor, here is the manual motor, is a brush type DC motor. Remember the manual motor, there is a manual motor, and it is brush type DC motor. It drives the outflow valve to the irreversible warm gear. All right. Okay, just look at this picture, right? You can see the automatic motors over there, and here is the gearbox feedback assembly, right? And here is the manual motor. All right, so now let's go to the last one, the safety valves. Okay, you can see the safety valve over there, right? Here is the sense line. This comes from the sense line. Here is the filter, and you can see the rough schematic. Here is is situated in the rear bulkhead, and here is the safety valve. You can see the safety valve filter over there, and here is the controller and the control ambient sense line port. You can see here, and this one the position switch connector. Okay, look, let's go to detail. So now this is the cut view. Okay, here is the cut view of the safety valve. Okay, you can see the internal pressure from this color. You can see the internal pressure, and next one, external pressure. This is the external pressure over there, and the filter is from the white color, and the poppet from the amber color. Okay, you can see this is the controller, and this is the diaphragm, and here is the position switch, and here is the rear bulkhead. Okay. All right, so the safety valve is of the diaphragm pneumatic valve type and consist of, okay, the safety valve is diaphragm pneumatic valve type and consist of a body, a filter, a moving valve element, diaphragm. Okay, here is the diaphragm, the moving valve element. This can move, right? So this is the diaphragm. So the pneumatic pressure controller sends cabin and outside pressure, right? So that consists of the pneumatic pressure controller sensing cabin and outside pressure, and a position switch for ECAM indications, right? The position switch, it sends the signals to the ECAM indication. And opening when the delta pressure, this will be open. Okay, the safety valve will be open when the delta pressure equals 8.6 or minus 0.5 psi. All right. Okay, so that is the end of this lesson. Thank you for participating in this lesson. So this is the final lesson in AT chapter 21 pressurization playlist. So the next playlist in AT chapter 21 will be general ventilation and avionic ventilation, right? So stick with my channel. I will upload more the videos regarding this playlist. So the first lesson of the next lesson, next playlist, stick with Aviation Engineering, right? So the for the first lesson under general ventilation and avenue ventilation, I will try to upload next week or after next week. So if you still not watch the lessons regarding AT chapter 21 pressurization system, so please watch from lesson 1 to lesson number 8, so then you will have a good idea about pressurization system and AT chapter 21. And also, if you still not subscribe to Aviation Engineering channel, please subscribe and please share these videos with your friends, relatives, anyone. And also please share these videos in your social media platforms, especially in the Facebook, maybe Twitter. All right, so that's all for today, and we will meet on next lesson. Have a good day for all of you.